When we talk about a piecewise function, that's exactly what it is. It's pieces of different functions that you're going to graph on exactly the same coordinate plane. So it's a combination of equations, and each equation is going to have a restricted domain. So when you see, for example, you're going to see a brace. So notice in the first row, for example, you see x plus 2. Well, we know graphically, what does y equals x plus 2 look like? That's just simply a line. So we know that part of this piecewise function is going to be a line. However, when we graph it, we're only considering x plus 2 for your x values less than 2. So each part of your piecewise function has a restricted domain. Then notice in your second row, you have another equation, 2x plus 1. Y equals 2x plus 1 is another line. And notice you have a restricted domain of x greater than or equal to 2. So a couple things you have to be able to do with piecewise functions: graph them and evaluate them. So for example, if I ask you to evaluate this piecewise function at x equals 0, you don't plug 0 into both functions. You need to figure out what domain does 0 fit into. Is 0 less than 2, or is 0 greater than or equal to 2? Where does 0 fit? Less than 2. So all you're going to do is plug 0 in for x into the first equation. So 0 plus 2 is just equal to 2. So now when you take a look at evaluating the piecewise function at x equals 2, again, you have to figure out what domain 2 fits into. So is 2 less than 2, or is 2 greater than or equal to 2? Greater than. So I'm going to plug 2 into the second function. So 2 times 2 plus 1, which is going to give me 5. So when you're evaluating a piecewise function, you don't plug it in anywhere. You've got to figure out where that x value fits in and just plug it into that one function. So x equals 4. Which function am I going to plug it into? The first one or the second one? Second one. Because 4 is greater than 2. So 2 times 4 plus 1 is going to give me 9. So any questions on how you evaluate a piecewise function? All right, so the next thing we have to do is we're going to graph it. So again, here is 2x minus 1 if your x values are less than or equal to 1. 3x plus 1 for x values greater than 1. So when I ask you to graph a piecewise function, what you want to do is create a table. Create a table of values for each function in the piecewise function. So notice I have a table already set up for 2x minus 1. I already have a table set up for 3x plus 1. Now looking at your restricted domain, what you want to do is you want to fill in those particular x values. So for 2x minus 1, I only want to graph this part of the function for x values less than or equal to 1. So I'm going to start with 1 as my x value. What's another x value less than 1? 0. What's another x value less than 0? Negative 1. And then another one would be negative 2. So now I want to find what the corresponding y values would be. So I simply plug these x values into the equation 2x minus 1. So 2 minus 1 is 1. 0 minus 1 is negative 1. Negative 2 minus 1 is negative 3. And then 2 times negative 2 is negative 4. Negative 4 minus 1 is a negative 5. Now, when you go to plot these points on your graph, you need to concern yourself with this very first point, this 1, 1. Look at your inequality. It's x values less than or equal to 1. Some of these points are going to be open. Some of them are going to be closed depending upon the inequality. So if you take a look at x less than or equal to 1, is that point going to be closed or is it going to be open? Am I including 1 in the solution set? Closed. So when I plot this point 1, 1 on my graph, I'm just going to use a closed circle here. 0, negative 1. Oh, 1, 1's right here. I know how to plot points today. 0, negative 1, and then negative 2, negative 5. Remember, you're just simply now going to connect all those points. I know graphically 2x minus 1 is a line, So that's what the part of this line looks like for my x values less than or equal to 1. So any questions on how I graph the first function in there? Now let's take a look at 3x plus 1. I'm only concerning myself for x values greater than 1. Let me ask you something. Would 1.001 have to be a point on this graph? Is that an x value greater than 1? 1.001? No. Yes?
Yes.
Yes, 1.1. Yes. So what you're going to have to do is you're still going to have to consider 1. However, what kind of point do you think I'm going to put at 1? This is just going to be a boundary point, so it's going to have to be open. Because graphically, you're going to have to show that 1.01. You have to show that 1.1. You've got to show the 1.5 graphically. So this is just going to be a boundary point. So 3 plus 1 is 4. What's another x value greater than 1? 2. And then 3, and then 4. So 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. And I know this is going to be off the graph at 13. Like I mentioned, this first point at 1, 4, it's just a boundary point. So we're going to represent that on the graph with an open circle. And then I'll plot my other points. And I know it's going to go off the graph, so it'll look something like this.
Wait, so when you do these graphs, you need like a boundary point?
Yes. These are functions. So remember, to be a function, it's got to pass that vertical line test. So you can't have two closed circles right here because it's no longer a function. It'll fail your vertical line test. So one of these points will be closed. The other one's going to be open. Otherwise, it's going to fail your vertical line test and it's not a function.
If x has to be greater than 1, why would we have to put 1?
So graphically, you have to show 1.00001. 1.01, 1.02. So you've got to somehow graphically show that this point's not included, but you know what? 1.1 is, 1.2, 1.3, 1.4, 1.5. You can't start it at 2 because then you're missing graphically showing all those points between 1 and 2. So that's why you need the boundary point. So always start right here. Your tables are always going to start at wherever the restricted domain is. It's just one's going to be a closed circle and one's going to be an open circle. All right, does that make sense to everybody? So now, what's the domain? Let's talk about the domain. And really, you have the domain staring you in the face. The domain represents all your x values less than or equal to 1, and then all of your x values greater than 1. So put those two pieces together. What do you think the domain of this function is going to be? Negative infinity to infinity. Or all real numbers, yes. Now let's take a look at the range for a minute. The range, you have to look at the graph you constructed in order to find the range. Is the range going to be all real numbers? No, because notice you read your graph reading it from the lowest point to the highest point when you're trying to find the range. So I know the graph is going to go from negative infinity. However, notice there's a break in the range. The range is going to go negative infinity to what? Negative infinity to 1, including 1. And then what happens? Notice 2 is not a y value in the range, neither is 3. So what's the next y value that I'm going to include in this range? I'm going to include a 4. Now, am I going to put a bracket or a parenthesis in front of that 4? Parenthesis. Remember, you're not including 4. There's that open circle there. Okay? So any questions on the range? Remember, the range is going to go lowest to highest when you're reading it. So now, if I want to evaluate this piecewise function, again, just like I did in the first couple examples, what domain does 1 fit into? Does 1 fit into the first equation or to the second equation's domain? The first. So I'm going to plug it in for x, which you actually already did. So f of 1, again, you're reading this when x is equal to 1, is simply going to be 1. Where does negative 2 fit in? What domain does negative 2 fit in? The first equation or the second equation? First. So that's going to just simply be negative 5. What domain does 4 fit into? 4 fits into which domain, the first or the second? This fits into the which one? Second. So when x is equal to 4, the y value is going to be 13. Okay?
Can you look at the graph view or not?
You can. I mean, sometimes it just so happens that we fill those values in the table. Sometimes they won't be. But yeah, you can look at the graph too.
Because I did up to 4 and then I said undefined.
No, that's why you want to make sure that you
Okay.
plug it in. Okay? Because these are sketches that we're doing. Our graphs are not drawn 100% to scale. Okay? So let's take a look at the next one. So like I said, when you're graphing a piecewise function, even though the tables are not given, go ahead and make a table for each part of your piecewise function. So 1/2 x plus 3/2. So there's my first table. My second table is going to be for negative x plus 3. You want to just pick about 3 points. It doesn't need to be a lot. You don't need a whole bunch of points. 3 is always a good number. So looking at 1/2 x plus 3/2. Again, x is less than 1. What's the first x value I'm going to fill in this table? I'm going to fill in a 1. And what's another x value less than 1? 0, and then negative 1. 3's good. Yeah, 3's good. If you need more, you can always plot more if you're not sure what the graph looks like. So when I plug in 1, what's 1/2 plus 3/2? 1/2 plus 3/2 is 4/2, which is just what? 2. When I plug in 0 for x, 0 plus 3/2 is just going to give me 3/2 or 1.5. When I plug in negative 1, negative 1/2 plus 3/2 is going to give me 2/2, which is just 1. Tell me about this point 1, 2. Is it going to be an open circle or is it going to be a closed circle? Open. Okay? So again, I can start plotting my point if I want to. So again, I've got 1, 2. I've got 0, 1.5. And negative 1, 1. So there's that part of the graph. Okay? So now let's look and see what negative x plus 3 is going to look like. Again, the domain for negative x plus 3 is x values greater than or equal to 1. Always start with wherever the restricted domain is. So we're going to start the table at 1. What's an x value greater than 1? 2, and then an x value greater than 2 would be 3. So negative 1 plus 3 is 2. Negative 2 plus 3 is 1. Negative 3 plus 3 is 0. Tell me about the point I'm going to place at 1, 2. Am I including 1, 2? Yes. So what kind of point's going to go in my graph? It's going to be a closed. Well, wait a minute. What happens? This is going to be a case where this piecewise function is actually going to connect. Some piecewise functions don't connect like we saw in the first example. This is going to actually be one where the two pieces are going to fit together like a puzzle. All right, so again, 1, 2, and then I've got 2, 1, and 3, 0. So this is what the graph is going to look like. So some piecewise functions will actually connect. You won't see the open circle because one of the functions will fill in that hole. So this is a case where the piecewise function fits together. Yes, Dennis?
Can both the functions have a built-in circle at the same time?
No, because then it's going to fail your vertical line test. Because it's, remember, it's got to be a function. These are functions, so it still has to pass your vertical line test. Now, going backwards, if I had no idea what these original equations were and I asked you to write the equation, there would be 2 correct answers. You would have no idea which one was x less than 1 or which one had the equal to 1. You can't tell graphically without the equations. But only one of them you'll not see. You can't have both of these have that equal to part here because then it will fail your vertical line test. Okay? You guys go ahead and evaluate those piecewise functions for me. Did we come up with these values? Okay. Any questions on finding the piecewise function? Yes. Sure.
For F1,
So where is it equal to 1? 1 is not less than 1. 1 has to be greater than or equal to 1. So you'd have to plug it into the second one. Because remember, 1 is not less than 1. So remember, when you're trying to figure out which piece it goes into, again, you have to plug it into the part where it's going to be equal to 1. Remember, this is just a boundary point. That's a boundary point. That's why it's open on the graph. But again, it got filled in eventually because the two pieces connected together. All right? But that's why I always start my table. I always circle that very first point and right away identify which one's open and which one's closed. That way you know which one the boundary marker is and which one's inclusive. Okay? Because both your tables should start at the same exact x value. Okay? What's the domain? All real numbers. Now let's talk about the range. What do you think the range of this graph is going to be? It's going to go down to negative infinity, to 2, and it's going to be inclusive. Notice there is no gap in the range. Again, it goes from negative infinity, and it stops right here at 2. So unlike the first graph, there's no break in it. Okay, it's continuous range. So any other questions on that one? All right, sometimes you have piecewise functions that have more than more than 2 equations. And sometimes they're not all going to be lines. Take a look at x squared or negative x squared. Thinking about your study of functions, what does negative x squared look like graphically? It's going to be an upside down U. So sometimes in your piecewise, but you're still going to construct them exactly the same way. You put your tables together. All right, so in this particular case, let's take a look at negative x squared. Again, the domain for negative x squared is negative 1, so I'm just going to fill in a couple values, negative 1, negative 2, negative 3. So just fill in a couple x values that are less than negative 1. Remember, be careful here. You're squaring the x values, but are we squaring the negative sign that's in front of x squared? No. So when I plug in negative 1 and I square it, that's going to give me still a negative 1. When I plug in a negative 2 and square it, that's still going to give me a negative 4. And then I plug in negative 3, that's a negative 9. Nope, because remember there's a difference between this versus this. In this case, if you're squaring the negative, it would become positive. But the only thing that's being squared is the x value. The negative sign is not. So remember there's a difference between that. Tell me about negative 1 on my graph. Is it going to be an open circle or a closed circle? Open. So negative 1, negative 1, negative 2, negative 4, and then a negative 3, negative. Now remember, I know negative 3, negative 9 will be all the way down here off my graph. This is not a line. It's a part of that U. So again, you just want to kind of bend that graph a little bit, because remember, that actually has a vertex up at 0, 0. If I was to graph all of negative x squared, it would look something like this. Oops. Wouldn't it? That's what negative x squared looks like. So it's not a line. So you just want to bend those points a little bit to show it's not a straight line like the other examples were. The other examples were all lines. Okay? So any questions on the first part? Let's take a look at the second part. 1 for negative 1 to 2. What does the graph of y equals 1 look like? Because that's really what we have here. We want to graph what y equals 1 looks like. What does the graph of y equals 1 look like? It's horizontal line. So notice this one it has a restriction of the smallest and the largest x value. So the horizontal line is only going to go from negative 1 to 2. So negative 1, 0, 1, and 2. And all the y values are the same. The y values are all 1. So when you have more than 2 functions in your piecewise function, one of those functions in this case isn't going to go down to negative infinity or positive. positive infinity. It has a definite start and a definite end. So your table is going to have a definite start and a definite end. So what you need to do is look at the beginning point and the end point and decide what kind of points you're going to put on your circle. What happens at negative 1, 1? Are we going to put an open circle or a closed circle? Closed. What happens at 2, 1? Is that going to be an open or a closed circle? Open. So then negative 1, 1 is going to be closed, and then 2, 1 will be open.
Why is 2, 1
Because it has to be less than 2. If you look at your inequality in the piecewise function, it doesn't have that less than or equal to part. So any questions on the second function? What's happening with this third function? What shape? Yeah, Dylan.
For the second function, are we not putting the other dots on?
You can if you want. I didn't. But again, since it's just a straight horizontal line, I didn't. But if you put the other dots on there, that's fine. Yes, Tony?
Why are all the lots 1?
Because it's just y equals 1. It's that constant function. Because remember, graphically, it's a horizontal line, and a horizontal line will have all the same y values. What does this shape look like? It's a parabola. And the transformation is the vertex is going to be where at 3, 2. The 3, 2. Remember, you shift the minus 3, shifts it to the right 3, and then you go up 2. Remember your transformations? So again, I want to build my table for x values greater than or equal to 2. So again, my third table is just going to be x minus 3 squared plus 2. Still going to start at 2, 3, 4. Fill in a couple x values greater than 2. So when I plug in 2 for x, 2 minus 3 is negative 1 squared, which is 1. 1 plus 2 is 3. When I plug in 3 for x, 3 minus 3 is 0. 0 plus 2 is 2. 4 minus 3 is 1. 1 plus 2 is 3. So take a look at this first point, 2, 3. Tell me what kind of circle is going to go in the graph. Is that going to be an open or is that going to be a closed circle? Closed. So I have 2, 3. I have 3, 2. 4, 3. That's why it's helpful to know a little bit about those functions. Remember, we know that this is a U. We just talked about how the vertex is going to be at 3, 2, so you're seeing this part of the U. Okay? So any questions on what that piecewise function looks like? You guys go ahead and evaluate it for me. Go ahead and evaluate f of negative 2 and f of 7 for me. Did we come up with negative 4 for f of negative 2 and 18 for f of 7? Okay? Let's talk about the domain and the range. Again, some of you may find it helpful to look at the graph. Some of you may want to just look at the inequalities to help you figure out the domain. So x is less than negative 1. So we're talking about all real numbers less than negative 1, correct? In the domain. We're looking at all real numbers between negative 1, and is negative 1 included in that domain? Yes. And less than 2. And then we're talking about x values greater than or equal to 2. So is 2 included in the domain? So what do you think this domain is going to be if you put all three of those pieces together? The domain is going to be what? Negative infinity to infinity. Let's talk about the range. Do you agree with me that this graph is not connected? So the range is going to be broken apart, correct? So let's take a look, first of all, at the first piece of this graph. Notice, again, read your graph lowest to highest. It's going from negative infinity, and again, it's going to stop right here, so what's the y value for that particular point? Negative 1. Is negative 1 included or not included in the range? Not included, so I'll use a parenthesis. What's the next y value? 1, just a single number 1. So you have a single number 1, I'm just going to put brackets around it. Because again, you've got to include 1. Is 1.1 in my range? 1.2? 1.3? 1.4? 1.5? What's the next y value I have to consider?
2.
2. And it's going to be bracket 2 to what? Infinity. Okay. So any questions on the domain or range for that one? Let's take a look at the next one.
Wait, is there a bracket?
No, there's always a parenthesis after infinity or before it. So here's another one. Let's talk about this last function, because we haven't seen one. All these functions have had domains where it's been an inequality. So what this is saying, I have a y value of 5 when x equals 3. Any thoughts on what that could possibly be on a graph? It's going to be a single point, exactly. So in a piecewise function, if you see x equals, and it's just one y value, this is how they're going to show a single point. So all I need to do is put a point at 3, 5. Yes, because it's x equals. You guys go ahead and see if you can build the table for the first one and graph the first part. We'll do the 1 over x part together. What is f of negative 6 going to be? Negative 5. Can you find f of 0? No, it's undefined. That's where your vertical asymptote is. Now let's talk about the domain. The domain's not all real numbers. What is the domain? It's all real numbers except what? Where's your vertical asymptote? Your vertical asymptote's at 0. So it's going to be all real numbers except 0. But is that a true statement? No. Because is this going to positive infinity? No, it has a definite stopping point. Where is it stopping? 3. So it's going to be negative infinity to 0, and then 0 to 3. All right? So again, you've got to be careful about not all